Now, a lot of this metering nowadays is all done electronically. It's done in the digital domain and much more accurate than it used to be. But what I want is one of the old analog movements, and getting hold of the actual meter movement for an analog ppm is not easy, but I did manage to find one, and here it is. You can see there are two concentric needles in the movement, a red one for the left channel and a green one for the right channel. Now, the movement is obviously only part of the story. We have to get the driving electronics for it up and running as well, because it's not just a matter of connecting this physical piece of kit across your audio. Now, the rest of the electronics I've roughly worked out that I can fit with a bit of struggle, I think, fit that onto 3 of these size burr boards, which actually will fit in my enclosure along with the meter. So as you can see, I have now managed to get the whole circuit onto 3 strip boards, 4 if you include the little PSU one at the end here, which we already looked at. And this one was the hardest one, this final one with the log law output stage. That one took a bit of doing to get all the components in on the design, but I managed to do so. Made a couple of mistakes as usual along the way wiring it up. Missed out the emitter pull down resistor for the last one of these log law transistors, which was confused me for a while. Obviously it's a bit of a rat's nest at the moment. I got it all wired up and got some input to it, and we can look at what it does. So I'm going to power it up, and I'm going to just measure the voltage here going in, so the AC voltage going into it, so we can just check that we have 0 dBu, which is 0.775 volts RMS going into it on both channels. Now, although you can see that it's working, I do have some issues.
You really have got a lot of issues.
Yeah, of what car magazine?
Actually, the biggest issue is that the reading is wrong here, because 0 here should be reading ppm 4. Why is it not? Because what I didn't notice, or maybe I did see it but ignored it, is that the original BBC design had at the input a couple of what the BBC quaintly used to call rep coils, but everybody else called transformers. And those transformers had a 6 dB step down. So actually, for 0 coming into the input, these boards would have received -6. So when I put 0 into the input without the transformers, I'm getting +6, which is what it's showing at the moment. So the system is accurate, but it needs a step down of some sort. I've also modified the gain structure of the first stage, because as I said, I didn't want the old BBC standard of a 3 dB instead of 6 dB attenuation for mono. So I have altered it for that, and if I press the mono stereo button here, you can see the red now sits exactly where it is, and the green one, which is representing stereo difference, goes down to nothing or very near to nothing. That can be sort of nulled out a bit with one of the pots here. The problem is I haven't quite got the gain structure right, because if I put it back into A and B mode, and I'm going to cut one of the channels now, let's say we'll cut the left channel, so we now have only one channel going, and again I go into the M&S mode, you can see that it's not right, because when that happens, both of these needles should have gone 6 dB down, because if you've got one channel, then you've got half as much in the total of the mono, which is the red one, and half as much in the total of the stereo, which is the green one. But the green one is still reading +6 or 5.5. So I've not quite got the gain structure right there. A couple of other problems I've got on this. On the final board, these 8-pin dip sockets I don't think are very good, because I only have to touch this and this moves around a bit. I don't think those chips are very tight in there. I could solder them in, but I think I've just got some rather duff sockets, or perhaps some ICs with very narrow pins. As I said, I'd use more modern op amps on the rest of it, the TLO84 quad packages. For this output stage I have to use 741s, even though they're quite an archaic op amp now, because I needed the null terminals, because you can see there's a couple of pots here which set the 0 as in at the bottom thing, so you have to be able to adjust those, and most modern op amps don't have that. So I had to use two 741s, and I don't know, they just, I'm not getting good contact on those, so I'll probably replace those sockets, and if that doesn't work I'll just solder the chips in. It was making me think at some point that one of the 741s had gone faulty, but it hadn't. You might see a couple of resistors here where they've been sort of doubled up and compounded, because it's a bit different from what we normally do on this channel. When you look at the average transistor radio from the 1960s, if there's a resistor in there that's 30k and you replace it with a 33k resistor, in most cases it won't make a blind bit of difference. Those are not high precision instruments. This is a meter, so you have to have, if it calls for 600 ohms, you have to give it 600 ohms, and I don't have any 600 ohm resistors, but I can put a couple of 300 ohms together, or a 560 and a 43 will be fairly close as well. These are all 1% resistors that I've put in these, and that is another issue that I've got. First of all, I mean, they're 5 bands, and you sort of, your visual memory of what a, say, a 33k resistor looks like is disrupted by the fact that the last band is now red instead of orange, and I've also got them on a blue background, which makes it very difficult to tell what the colours are anyway. So with these things, I absolutely hate using them. I've pretty much always got to put an ohm meter across them before I put them in to check that I've got the right value. There's just one more thing. You can see at the moment we're getting the correct, everything's very wobbly here, we're getting the correct response. So if I turn the incoming signal off here, you can see it decays quite slowly. And if I put it back on, you can see it's got very high attack time, which is good. It's exactly what we want from a PPM, is that you want the peak to show pretty quickly, but you want it to decay fairly slowly, and it does seem to be doing that correctly. However, if we look at that on program, there's a slightly different story. So I put some program in here now, as opposed to tone. There is a slight difference between the channels, and this is mono, so which means that these two should be moving together, but they're not quite. They drift apart a little bit. Now, the issue here, I think, is whereas it looked okay when I had tone on it and I was just switching the tone on and off, when you get a more dynamic signal, what's happening is that the time constant, when we look at the diagram, this time constant is not quite as stable as it should be, because what happens is the tolerance of these 33 microfarad electrolytic capacitors comes into play. All the resistors are 1%, so I'm not bothered about those. They're pretty good, but the tolerance of electrolytic capacitors is notoriously bad. So I think what I'm going to have to do is go through some of my 33 microfarad capacitors and find two which are pretty close, and I think that problem of the needles not quite being in sync on mono will then go away. I hope so anyway. So what have we got to do? First of all, we're going to look at the gain structure of the first stage. Secondly, we've got to replace those dodgy IC sockets, and then we've got to look at selecting values more carefully for those electrolytic capacitors that set the decay time. Okay, well, the first thing I do is look at this board and change the gain structure, which is mostly by replacing some resistors around here. In the documentation, it suggests that you can calculate this M&S resistor here, or the S-balance resistor, by looking at the other resistors' values, but I couldn't really get that to work. I don't know if that formula was added later and they maybe did what I did, which is to put a variable resistor in there with this pot in mid position and basically tweak it until I found out what the optimum resistance was, and it turns out to be 22k, so that's what I put in there. There was another issue on this board, which was that there was a break in the track between these two diodes here, which meant that the half-wave rectification wasn't working properly on the left-hand channel. So that was the thing that was moving about when I was thinking that there was a bad connection on the output board. If we go to the output board, I have replaced these two IC sockets here, because the sockets were a bit rubbish and weren't holding the things in very tightly, and it is better now. But having done that, as I said, it exposed the problem further back. This is often the case when you're doing these things. Also, going to the middle board, these two capacitors are the ones that define the time constant, or the decay time, or the attack and decay times. And I've found from my collection a couple of ones that are more closely matched than they were before, which hopefully gives us a better look when the signal is mono and the needles should be moving together. So let's get it all plugged in and have a look at the alignment. Right, so I've got it plugged into the signal generator here, and I've got this little chart which I use to show us the relationship between RMS volts on the input and the dBu level. and the ppm markings that go with it. So ppm 4 should be 0.775 volts. We're not quite on that yet, as we can see. So if I alter that slightly, so I've got that on 0.775 volts now, and it's a bit difficult to tell really when you look at it in the camera and I look at it here. I can see that's pretty dead on ppm 4, but I'm not sure if it quite looks like that on the camera because of parallax, which is always a bit of a problem with these meters, but you're not really generally going to read them that accurately in normal use. Obviously my right channel is now wrong, so I'm just going to raise that a little bit to get it in line. I'm not showing the voltage on the right channel because I've only got 1 meter plugged in, but take it from me, they are both on the same thing. So here we are, 0.775, and we're dead on ppm 4. If I go down to the bottom of this table, the lowest number on it is 0.195. So if I take that down quite a bit, so that should be on ppm 1 now, which we can see it is. You'll notice also that we have 1.5 here. That's because if we look at the circuit diagram, we can see that the designers of this circuit have ludicrously come up with this adjustment pot for set 1.5. I mean, why would you have a calibration pot to set a mark that isn't actually marked on the scale? So I have to sort of guess where 1.5 is. I've already done the calibration, but I'll move it up to what's it supposed to be, 0.245. So let's move it up to that. And that should now be on halfway between 1 and 2, which in my professional opinion, with my ever decreasing eyesight, I think it probably is 1.5, so that's okay. I'm then going to go up to 2, which should be 0.309. Because of the log law, it takes longer to do as you keep going up the scale, so I'm going to speed some of this up later on. So 309, and really, to be honest, you don't need to be 3 digits. I'm just going to wind this back to 4 on each channel now. Now the other test I'm going to do here is to put it in M&S mode, and you can see that we have still got ppm 4 on what is now reading M, which is a red needle, and nothing at all on the S needle. And if I cut one of the channels, you can see that the S goes up quite a bit and the M comes down. They should meet at -6 at this point. The other thing to check is if I change the phase of the second channel and move that up to 180 degrees, then the S goes high and the M goes low. In fact, not quite there yet. That's about it. Because with the channels in reverse phase, then the difference signal is 100% and the sum signal is practically nothing. So that all seems to be working really. We'll just have a quick look at it on program.
Let's just get as many teams up there as possible because, you know, we've had a bit of a dip recently. We're third. I hope we're going to finish fifth.
I was going to ask you about that, Steve. Are you confident you'll be playing Champions League football next season?
I think you see all there's a bit of a discrepancy between needles in mono. In fact, my microphone's not entirely central, is it? Let's fix that. They are moving together a lot better now that I've matched those capacitors up. So I think that's really as good as I'm going to get it, and I'm not bothered about the slight minor differences that we're getting there now. So I believe all the electronics is now done. The next stage is to get it all into a box. That's probably going to be the most challenging bit. Well, I've spent a lot of time on this channel ripping into other people's construction methods, so I suppose it's only fair that people should now have a go at mine. So I've mounted the meter on this, the panel of this thing. I cut out a hole in it to mount the meter onto this, basically a plastic box. Problem is, the boards, you can see, are pretty much populated right at the edges here. So there's not really any room for putting in nuts and bolts and things like that. But what I've found is useful for this is this stuff. Now, this comes in like A4 sizes, and it's for holding documents together. You know, if you don't want to staple them, you basically just pull this apart and stuff the stuff your pages in, so you can put, you know, a load of pages together in a sort of folder. And this is actually quite good for holding Veroboards, and you can just cut it up into bits. And as you can see, I've cut bits of it here and put them into the front panel of this box. So yeah, these boards just slot into these guides here, and then the whole thing just sits back in that. Now notice power supply isn't in here. I put that in a separate box and have connected it with one of these multi-way connectors here. This is quite useful having all these connections, because if you remember, we've got a three-way rail of plus 11, minus 10 and 0, and also I wanted to bring in the 24 volts out of the power supply brick as well, and the reason for that is because illumination of the meter, I put a little LED strip in here at the top which will illuminate the meter through its top cover, and that comes off the 24 volts supply via a resistor which you can't see but is in this heat shrink. You'll also notice I've got a couple of 3.5mm sockets for the audio side. These two are just paralleled up. The reason again for that is because the meter is going to sit on the output of something, but the output is going somewhere else, and rather than have a Y connection outside it, I thought I'd just put two parallel 3.5mm sockets, stereo sockets here, so we can just go in either one of these and the other one will go out to the amplifier. So let's stick it all together and have a look at the final finished unit.
Jackie Bramble's back tonight at 7 o'clock. Most Wanted Greatest Hits. Then, after 8 o'clock, the wonderful Francis Rossi, Out of Status Quo. We'll be talking to Jackie. 10 o'clock, Andy Crane, and Ken is back tomorrow from 10. And the drama reminder on day 3 next.
Greatest Hits Radio.
How did Butlins Big Weekenders get their name? Because we go big. And this year, we're going big on our epic Decade Weekenders.
On a cold metal thing, what do you recommend in this crucial 15 to 25 minutes?
A wooden board? I don't know.
More parents are choosing EE Broadband, the UK's fastest growing broadband provider.
To verify, see ee.co.uk/claims.
Online.
On DAB Digital Radio.
And streaming on Rayo.
This is Magic Classical.
Top stories this hour. Aid centres in Gaza.
I'm not sure about Magic Classical really. Is there room for a third classical music station in the UK alongside Radio 3, which is rapidly becoming like Classic FM? There's far too much film music on it for my liking, although some of the presenters are not too bad. Anyway, bit off topic there. You can see it's in place here now in front of my submixer and working pretty well, and I'm quite pleased we finally got this together. I've had this meter for ages and always been trying to get around to building this project, and thought it's quite a lot of work and do I really want to do it, but I'm quite glad I did in the end. This is a bit of a diversion from what we used to. I occasionally do these and I know they're not always very popular with the regular viewers, but hopefully it was of some interest. I'll see you on the next one.